React Native. My name is Nia. I work at Healthy, and Healthy is practice management and telehealth software. We help health organizations basically do their jobs. That's part of what we do. So now back to React Native. I actually am not a full-time React Native developer. I started out as a React JavaScript, like web developer, and then got thrown into projects that happened to have React Native. So my role has this weird balance where I get to do both, and I'm constantly switching contexts. So when I first got thrown into React Native jobs, I was like, oh, it's React, it's the same, right? It's as easy as writing React, right? And that was my opinion until somebody said, can you add some animations? That really threw me for a loop, because animations in React Native is hard. There is no DOM, there is no CSS, and React Native has its own language for movement. Basically, you can't tell it to do the keyframe stuff anymore. This is all like DK, interpolate, use native thread. I mean, the first time I started looking at this stuff, I was like, what the? I feel like I'm back in elementary school trying to learn ABCDs. It was pretty hard. And the more I dug into it, the other big thing that hit me was performance. Anytime I kind of like figured out a basic animation, I got just throttled with the app being really sucky. And that's where I started like digging more into this concept of declarative versus imperative. For anyone who doesn't really know that concept, it really means like declarative, like declares the logic of a computation without describing its control flow. It's sort of like asking your roommate to clean up. You don't really give a shit how they clean up, right? The place is clean, that's what you want. Versus imperative specifies how the function should be executed. That basically means you're telling your roommate now they have to use this special brush to clean and this special vacuum to do the cleaning, and they have to do it within this time frame. Yeah, your roommate's gonna hate you, man. So with React Native animations, the thing I learned is declarative is better, generally. And then we move into libraries. There is tons of libraries for React Native animations. You're going to look there and go wonder, like, what the fuck do I pick? There's also the built-in options of animated API and layout animations. The difference being with animated API, it helps you with smaller, like granular interactive control. So like, you want to make your little loading screen, right? Versus layout animations handles like the exit and the entrance transition. So when you're like sliding between screens. And then all the different libraries that are listed are just a small portion of the many libraries out there. There's new libraries popping up every day. The ones we're going to look at through this talk is React Native Reanimated, React Spring, and another library called Modi that's based on Reanimated. And just FYI, Reanimated is one of the most popular animation libraries out there for React Native. It's really cool, but it's got its quirks as well, right? Like every other libraries. We'll dig into some of those. By this point, all I know is that I know nothing when I started my journey into figuring out what the hell animations meant in React Native. So what I like to do is actually look at what actually happens when you animate. Like when you say, hey, translate this box, move it from this point to this point. What actually happens with React Native? What happens on your device? Why is there that performance issue that we get throttled with, right? So now the animated API, that's literally what everyone has to start out using when they're figuring out animations in React Native. It is built into React Native, so everyone starts with this, right? This is sort of the thread, like the structure of what happens within when you trigger an animation, right? There's a UI thread, a JavaScript thread, and then the native thread. And all three have to talk to each other in order for your animation to work. So let's just step through each of them and see what responsibilities they take, right? Oops, there we go. So the UI thread basically kicks off the animation. It's like, hey, start it up, let's move on. I want to move my box from point A to point B. It just sends that little snippet of code you have written to the JavaScript thread. And then the JavaScript thread drives the animation, uses the request animation frame to execute on every frame. It basically, every frame is basically 1 frame per 16 milliseconds. It's basically saying, hey, re-render the frame with this new position now. So if point A is 0 and point B is 100, at every 16 milliseconds, it's saying the next one is 10 and then 20, and then move the box from 10 to 20 to 30 and all the way to the 100, right? So it's like figuring that stuff out. Then it basically calculates all that positions and passes it to the native view component. From there, the JS thread is really chugging along there. It updates the native props. It's telling, hey, this is all in JavaScript. Let's start getting this into stuff that native is going to understand. And then sends it to the native bridge, basically the part where it converts the JavaScript into your iOS or your Android build stuff for the native thread. Whew, that's a lot of work. I'm just tired from talking about that. And then we get the native side, which basically goes, thanks for this new little snippet of code. I'm going to tell the UI to go do this now. That's it. That's all that work happens on the JS thread, and the native and the UI thread just do their one little step and then sit back and relax, right? This is where we hit the performance problem. If your JS thread is now also fetching data and computing your data and arranging the array of data or whatever, while doing this animation, it becomes really busy and then causes frame drops. That's literally when you see an animation just pause and then drop and start somewhere else, and it's kind of janky. That's literally what's happening. It's because it's trying to re-render the frame every 16 milliseconds, and it just can't keep up. So it skips to 4 frames or 5 frames ahead, right? So you see the weird little jank. Then Animated API came out with a solution. Use native driver. This basically moves all of that work the JS thread does into the native. The Animated API actually produces this serialized nodes. It basically takes all of that code, puts it into one thing, and the box needs to move from point 0 to point 100. It tells it that, and then it kind of figures out what all the little intermediate steps are from point 0 to point 100, and then puts it all together into this little bit of snippet of information and sends it once down to the native thread. Now the native thread is literally doing all the rest of the work, telling the UI, hey, box is still at 0, 1. Now it needs to 0, 10. Now it needs to move to 20. And it's literally doing that one-way communication to the UI thread, which leaves the JS thread alone to do its own job. So now you can fetch your data, arrange your data, navigate all of those other things you need to do, totally happily doing it. But now here comes the question. How does the native thread know the values between point A and B, for sure, right? Because what if it's a pan gesture, you're moving physically the box, you're grabbing it and then moving it, and it knows it's supposed to move at this kind of thing from point A to point 100 or point 5 or whatever. How does it figure out the intermediary steps? What does point 10 look like? What does point 20 look like? That's where we go into one of those weird words that we saw earlier, interpolation. I still struggle with that word, so if I skip over it, excuse me. Interpolation is sort of a way React Native guesses, estimates the middle values for that. So if x starts out at 0 and the end range is 100, all the in-betweens, React Native sort of just guesses it. It's a way for it to estimate it. It's a way for it to like assume what those values could be. There's a nice little YouTube link at the bottom there. I know it's a little small, but that guy does a really amazing job at explaining interpolation in detail and showing really good samples of that too. It was a great way for me to understand what it was when I was first starting to learn. And I actually like copied some of his content there because, hey, he did it really elegantly. His YouTube channel is Evening Kid, basically. So now we're going to think about interpolating opacity. So like, let's move this from translating x 0 to 100, we also want the box now to have an opacity of 0 to 1. So it's, again, we're trying to tell React Native, while you're moving the box from 0 to 100, we also want the box to now have an opacity starting at 0 and then end at 1 when translation is at 100. So now it's two different values here, right? Like the range for translation is 0 to 100. The range for opacity is 0 to 1. How do you like tell the middle, which is 0.5 for opacity, right? This is where interpolation really plays in from the animated API. It actually is really good at figuring that value out for 0.5 and estimating it. So all those little intermediate middle values, it'll figure out for the opacity within the range for the translation. Now, I know me talking and telling you what that is probably not as helpful as looking at what it actually is in code. So here is just the animated API doing a loop animation of like translation, and then the same thing of like outputting opacity as well. So here, const translation equals new animated dot value. That's how you're starting out the animation at value 0. Animated, that part animated right here, actually comes from the animated API, which is part of the React Native library. And then you put in your loop part, the timing. The to value here is saying the end range for translation is 100. Use native driver. This is the bit that is literally saying, put this all into the native side, like we mentioned before. And then here, you can see the interpolation part, like right here, translation.interpolate. The input range, interpolate takes two things, right? The input range and the output range. Input range, you can see it says 0 to 100. That literally is matching the same range for the translation. Translation is 0 to 100. So I'm translating when translation is at 0, opacity has to be 0. That's my gap, like that's my range where it can sort of estimate the middle grounds. Feel free to stop me if I'm going too fast or if this is like a lot of concepts being thrown, because it was a little hard for me at first too. So now this moves into the concept of extrapolation and clamping. Because great, we have our animation that goes from 0 to 1, exactly with the box going from 0 to 100. Well, the problem with that is, what if you wanted the box to start, being opacity, start changing opacity when translation is at 25? So when the box is at 0.25, and you want the opacity now to be 0, and then move forward to 1, and end by the time translation is at 75, not 100. So you want the box to be moving, and then continue moving, like before and after the opacity is done, kind of thing. This is where extrapolation and clamp comes into play. Extrapolation is basically a way of saying, hey, let me like define that range for you, and clamp is sort of like setting that range for React Native. Like React Native, the animated API is pretty good at guessing it, and you'll see some weird behavior if you don't add that extra bit. But this is like by clamping here, it's a good way of like basically saying, when translation is anywhere between 0 and 25, opacity should be 0. It doesn't matter. Opacity should only start changing after 25, right? And then when translation is anywhere between 75 and 100, opacity should remain 1. There should be no change to opacity. So this is a way of like forcibly defining that range. That way React Native and like the animated API is not sitting there and guessing it and trying to like put it in there. So this, at this point, extrapolation literally is the opposite of interpolation, where you're specifying something. And clamping is sort of like a way of just putting those stop gaps, right? This is what it actually looks like in code. You can just write extrapolate clamp. So it's the earlier animated .image bit, the same code as before. The only change being our input range changed to 25 and 75. And our, we had the extra line of extrapolate clamp. Now, you can also specify the left side and the right side clamps separately. So you can say extrapolate left clamp needs to be at like something different, or extrapolate right to be something different, which lets you like adjust the ranges or like let it guess on one end and not guess on the other end, right? So there, we've animated something, we're done. This is, you know, we don't need all the libraries. We've got everything, we've solved the issues, used native thread, and we've got performance all figured out, right? This is it, this is the end of the story, right? Makes our life simpler. What more do we need? Well, sad to say, there are limitations with animated API, especially with the use native thread part. Not everything that the animated library that currently can do is supported by the React Native built-in animated API. So there's a little difference there. There is an animated library that then React Native adopted into their own build. And that stuff, the built-in API only does certain amounts of stuff that the library itself can do. With the main limitation being that you can't do layout properties. So like the exit, entrance, transition, so like when a slide comes in or leaves, those kind of things, you can't really animate those well within the built-in API. And things like transform and opacity may work, but things like background color doesn't really work well. In fact, like with use native thread, you can't use, you have to turn it to false when you're changing color, for example, at which point all of that performance you've just tried to put in there goes away. And another one is that animated event, which is like on an event, do something. It'll only work with like direct events and not bubbling events. That means it won't work with like pan responder, but it'll work with like on scroll. So those are the current limitations of the built-in library functionalities, right? So this is where all these other awesome libraries come into play. React Spring, Modi, and Reanimated. Now, Reanimated, there's version 1 and version 2. Version 1 is very popularly used. It's one of the most popular ones there, but it's harder to read and harder to work with, hence why version 2 came out, which uses hooks. The big awesomeness is that it uses hooks. We're just gonna like start digging into some of these three libraries really, and look at the differences there and why like you may use one versus the other kind of thing. So let's start out with React Spring. The big thing about React Spring is it's a physics-based animation library. How many of you have heard of that? Cool. So physics-based means it behaves like how you would expect things to behave in the natural world, right? So you throw a ball, you're not telling the ball to arc at this certain degree and then fall during this time. You're literally just throwing the ball and it falls. And it may, if it has bounce properties, like if it's made of rubber, it'll bounce. If it's got a mass of something and a tension of something, it may behave a little differently, right? And that's sort of how React Spring works, is instead of duration, you use like mass, tension, and friction to sort of define your animation, which makes it have a lot more smoother, like a flowy movement to your animation, like a more realistic feel to it, which is great. And the best part is, it is built on animated and React Motion. React Motion is where the physics part of this, the spring-based animations come through. And it still uses a lot of animated, the library's core functionality. So a lot of the functionalities you'd find there is still in React Spring, and can bring those two together. Another big bonus was when earlier on, before Use Native Drive and all of that fun stuff came out, the first versions of Animated's API, and I believe some of the older stuff still does it, is more imperative rather than declarative code. So the performance there, again, was much more painful, versus React Motion is more declarative. And React Spring brings in a lot of that same kind of declarative language to help with performance into the same concepts that Animated does, right? So you now get to use Animated's built-in, or the library functionalities with declarative code, which makes your performance a lot better. Oh, I just said all of that. Great. And there's a lot of useful primitives, can interpolate mostly everything. Oh, and the best thing is that it can commit directly to the DOM instead of re-rendering a component frame by frame. So that literally means, you see how that little, we were talking about frame drops earlier. That happens because the drive, the request animation frame drive, is re-rendering the frame per 16 milliseconds. This just says, screw all of that. Just don't re-render at all. Just let the DOM do its thing, kind of. It works that way, so it moves seamlessly. And it works on web and mobile. This means whatever you do in React Native there, you can use the same logic, the same knowledge you have there into your web animations. So for developers like me who don't always get to work on React Native but get moved back and forth, this is a great bridge. There's less stuff that I have to try to remember in differences, but I still get to use the same kind of logic and thought process for the libraries there. And now we have a little snippet of React Spring. So you can see it's actually using, so this animated view here, animated, that comes from React Spring. It's how I'm defining that this is the component, the native component that needs to be animated. And this use Spring hook, it's literally hook-based. It's where all my definitions for what my animation needs to be is defined, right? So here, I'm rotating an image, right? And I'm saying it starts at 0 and it ends at 360, and it needs to loop. It needs to go on forever. And instead of duration, you notice I have stuff like mass at 0.5, tension to 100, friction 100. This again is how I'm saying what the rate of spin is. How fast do I want it to spin? And how do I want it to behave, right? By changing these numbers, I can make it spin faster or bounce when it ends, or spin slower and more sluggish, like you'd rolling a heavy rock kind of thing. So again, basic physics principles applied here. But you can look at the code difference to see how much more readable this is versus the animated API one itself, which is one of the reasons why I love how neat that stuff looks. Now, we're going to skip to Modi a little bit. At the end of this, I'll show you what that earlier code is in action. I just don't want to skip in between all of this stuff and try to get my yarn and stuff running. So let's skip to Modi a little bit and go through the concepts there as well. Modi, the best part is it's built on Reanimated V2. That means Reanimated V2 has all the hook compatibilities and all that fun stuff. Modi takes all of that and puts it into components, so you just pass an object to that component, right? You're not trying to figure out all the little nuances that Reanimated provides. It simplifies it quite a bit. V2 also has this really cool functionality for performance, where it actually uses a separate JS context to run worklets. So now, worklets are small JavaScript functions that you can specify very complex animation in. that instead of it all like being squished into a serialized node and then sent to your native thread, you can have it run next to your JavaScript thread without it throttling your thread. It's actually running on the separate little context bit, and it's doing its thing by itself. And it's like, this means like you get to have a lot more complex animations run while your data is updating or fetching or doing whatever else you need it to do. The best part about Moti specifically is, yes, it includes the performance of Reanimated 2, but it also adds a lot of other stuff. It learned from Framer Motion with the exit and entrance animations and transition stuff, and it includes that. It also includes React Spring's like Spring animation components. And it is mobile first and does support web, but the flaw here is that it supports web as long as you're using React Native Web. I haven't seen a lot of like React itself functionality for it, even though they say it's coming. The guy who built it, Fernando Arroyo, actually just did a talk about it for Next.js, which he does walk through how it works on both Next.js as well as a React Native app. So it's a really cool talk to watch if you ever get a chance to. It's also on their home screen if you want to go dig into that as well. This is what Moti's code looks like, right? So here, instead of me having a hook or any of that, I'm actually just pulling a component from Moti that says Moti image. Like this is my image component. And that component is now taking my transformation, like my animation of from rotate 0 to, like it starts at from rotate 0. I don't have to specify the two separately. I just say animate transform to rotate 360. So I'm saying it's starting at from, now the animating part is going to 360 degrees, right? So it's again doing the same loop, loop of circular movement there. And I'm specifying the type here by saying timing. So I'm actually saying, hey, this is a timing animation versus a spring animation. And it behaves differently based on that. If it's a spring animation, I wouldn't be able to spend it pass in duration. I'd have to do the same thing as useSpring did with mass, friction, and tension, and those other kind of values. Versus here, with the timing one, I can just go back to what we all know in the JavaScript world of duration. The repeat reverse part, so this is another thing that you might also see in React Spring. It's where if you don't specify not to repeat the animation in reverse, because by nature, if you pull something really hard, you have the counterclockwise movement as well, right? So it's the same concept where if you move the circle in one direction, it'll start actually animating in reverse direction before it ends the animation. So by this way, you can actually just say, hey, don't go anti-clockwise, just finish one circle and then start the next circle. Don't try to mimic the physics-based movement of going backwards as well. Any questions so far? I know I'm throwing a lot of concepts really quickly here. Cool, I guess I'm really nice right now. So now Reanimated V2, I'm just throwing in what that difference looks like versus Moti versus Reanimated. Why I personally kind of prefer Moti right now. I'm hoping Reanimated keeps moving into more neater looking code, basically. So here, you actually have to specify a shared value. This is a way for it to know this is the value that it's going to be starting at something and then ending at something. And then you use the use animated style hook to then specify, hey, this is a repeating animation. It's got a timing with timing hawk. And there's it's going to do 360 degree movement. I want it to repeat 100 times, and false is for the reverse movement, basically. This is not a full loop. This is just me dicking around with my code. And then the transform here is the actual style, and then you pass it into the animated.view. So this animated part, again, comes from React Native Reanimated, not the animated API. So just to clarify that. Animated.view is a way to tell the Reanimated library, this is the component that's the animation is happening on, and I'm just passing it in as a style object. So it's not a big difference from what Modi looks like versus what this looks like, but because of the hawks, I just find it a little bit easier to debug when something goes wrong with Modi versus this. But again, Modi is built on this, so if you know one, you kind of know the other. Now, this is the portion of the talk. We're going to go into some live code. And it's not like some crazy finagled awesomeness. I'm just going to show the same samples we were talking about in Expo, basically. Let's see. Oh, so let's start with React Spring. So if you ever go to their URL here, this is their logo. But you can see right here, that really cool, like, bouncy movement. That is all of what React Spring embodies, like that sort of like natural physics-based movement, where that ball, it almost feels like a real like rubber ball stuck inside a spring, right? And I found this really cool code pen that like talks about it, like that actually shows what the code looks like. Yes, this is a lot of information, so we'll just go through it very carefully. They're basically moving an SVG and moving that SVG for the ball in here. So the really cool, interesting parts of it is this use gesture, that comes from the React Native gesture library. That's how I'm able to grab the ball, basically. Then it's doing all the math to figure out like where I'm grabbing it, where I'm pulling it, and what those values need to be. And then it's sending it into the Spring to go ahead and do all of that fun stuff. So just like a cool little demo of like what that is. Again, this code pen is public. You can literally type in React Spring logo, and you'll see this code pen pop up as one of the first ones, so you can dig into it more for more information on that. Now, let's look at some of our stuff. Let's see. Can anyone see that, or is it too small? Okay, one sec. Hopefully Yarn doesn't break on me right now and everything works as seamlessly and effectively as I'm hoping it will. Let's see. Okay, perfect. So that's working. How about now? Cool? So this is the earlier animated built-in React Native animated API. So again, this is the limited one where I'm using it to use native driver and all that fun stuff to try to make it as performant as possible. And I'm not even doing a very complex animation here. All I'm doing is taking an image and spinning it for a loader effect and adding opacity like for the loading part to it. So basically that animation is right here. This is the animation that I'm doing, literally this little bit, where you can also see how the animated API text here is like sort of fading in and out. The fade, it like has a little jarring effect of like once it's fully at 100% of going backwards. So that's where, because of the clamping that I've set up here, where I'm saying, hey, clamp left or clamp right, that's sort of what's doing that. The little bit of jarring, and with a little bit more work on this, I could probably make it more smoother by adding an extra value for the before and the after to make it feel a little bit more smoother. So basically, you could actually add another like value here to say, hey, like I want this to be more eased in or eased out, and all that fun stuff. But this is again that same animation. with the spinning. Easing is actually not I know with like CSS we could just say easing and it'll just does its work, but it's actually another function you need to pull in from React Native for it to like understand what easing is, and that's how you can say easing.linear and it'll do that linear movement for you. So that's our little animated API doing its fun stuff. No problems there, right? Now let's move to the React Spring one. So this is where you can see that almost like stop and movement, where it's almost like a wheel spinning and then it stops, right? So like you trigger something and it just moves really quickly, it stops, and then it starts again. That like almost natural feel is what the whole Spring animation stuff is coming from. Where is it? There we go. So here you can see the code for that. So use Spring and animated bit, where I'm telling the component needs to be animated, is coming from React Spring native. So now, because React Spring does not only React Native, but like Ionic and like web and other platforms, you can actually just specify, I only need it for native, I don't need all the other bundles, so you can specify that right here. And again, all of your animations from the use Spring is going into the style as an object, right? Right there. So this is the loader text. This is the text itself that's moving in and out. I separated them out just so I could play with them separately and not have it like do weird things together. And if you notice here, for the loader text, the opacity of the text going in and out, I've put a duration. So the latest version of React Spring, some of the more latest versions of React Spring, does allow you to have timing animations, not just the physics-based ones. So you can do a duration in there and have it like work as expected. But here we have our mass versus tension 200. This is the part that is controlling the image that goes in circles. Our little cookie that's circling right here. This is the part that's handling that. So we can, for example, change mass to 300. Hopefully, I may just need to, sorry, accessing the terminal while in presentation mode is not as intuitive. So let me just refresh, reloading my bundle there. And it moved, there we go. So now our little use Spring animation here is moving a lot more slowly. You can see how it almost like spins backwards a little bit, right? It's sort of like the concept of like moving something really heavy and eventually just kind of moves back a little slowly and then moves forward again, right? So just by changing mass, the effect of that animation is now very different. It's not that little fun little easy circle wheel, it's a little bit more heavier. Pretty cool, right? So these are like very basic ones that I'm playing with. Feel free to like go dig in, and there's really cool stuff you can do with SVGs as well. So like that earlier Spring animation with the ball, their logo, that's an SVG that they're digging around with. Now, we're gonna go quickly to, oops. Control tab, there we go. The Modi one. So here, Modi also has image, and all I'm just saying image as Modi image. That way there's no confusion between the React Native's image component versus the Modi image component. And again, Modi also has view that you can use, Modi view component. So the same loader text versus the image, I'm separating out those pieces into separate functions just so we can very clearly see the differences. But here, the whole view component is being animated with timing, and I have the duration. It's very similar to what we just saw with Spring, with use Spring. Very same concepts, not a lot of like knowledge-based like differences. It's sort of very intuitive in that sense. And then when we move into our image, you can see, again, same concept, very neatly laid out. It's just taking that rotation, the from and the animated to bits, and then what kind of transition. So I can make this into spring right here. And you can already see like TypeScript is like erroring out for me here saying, hey, timing, like spring doesn't take duration. Like I, at this point, have to like remove this. And I can do like different configurations for that based on, and see the differences in that as well. So before I just make those changes, I do want to just show you what the Modi one looks like without changes. And it's very smooth, very neat, not a lot of complexity there. But you can also see how the fading in and out is not as jarring as the animated API or the Spring one is. It's a little bit more sleeker. You can make this even more complex using the worklet bit that I was talking about for with the JS context. So if you wanted SVG animations and stuff, you can use that. And you can also use gestures in here with React Native gestures to like play around with those animations. But now we can just change this to Spring, rerun our code, and see what happens. Of course, I have to remove that. Let's see. All I'm doing at the bottom here is like rerunning the JavaScript bundle, because sometimes if you don't do that and you've changed the values, it won't show show the next bundle, like the next transitions you're expecting. So and we go to our Modi, you can see the animation just changed. It's sped up because I'm now putting a default configuration for mass, tension, or friction. Is using the default value of mass of like 1 and tension of like, I think 1 and friction of 1. So there's not a lot of friction to it. There's not a lot of, it's not heavy, and there's not a lot of like tension to it. So it's just moving very quickly. And you can see that little wobble as it's coming back. So that's like that spring animation concept. But yeah, that's basically everything I've got for you guys. So that's everything I've got for you guys. You guys have any questions, concerns? Yes. Yes. So for Spring and Modi, there's a little extra bit that you have to add in for the Android build. That does the trick. But there wasn't a lot of big performance stuff, differences there. But again, it like depends on the animations you use, right? So the thing I liked about Modi was that it was a little bit more simpler, like even like understanding what the code was doing and seeing where the performance lag was a little easier. And because it's using the JS context part that Reanimated V2 is built on, it really does help with performance for like really heavy animations. So I've noticed some differences there. For Spring, thing with Spring is I haven't done a lot of like heavy animations with it. Like a lot of the things that I play with is like SVG animations, more small things for it, right? Not a lot of like entrance and exit ones, even though I know it does support some of them. I've just found it harder to like understand, like play with it, right? There's not a lot of samples or documentation to go dig through that as well. But for Reanimated V1, you will see some differences between Android and iOS. Like there will be some jank between that. I believe that part of that has to do with just the fact that in Android, the way it bundles, like the animation part bundles is different. So I'm not fully sure about that though. Hopefully that answers. Any other questions? I'm sorry? Oh, rotating your screen? I've seen not so much for usability. I've seen like the ones where they're like fun ones, where it's like showing wobbles and stuff like that. So there's a lot of those. Yeah, you can actually like just go and look at like use Spring or like React Spring wobble animations, and you can play with those. The thing that you might have trouble with is the layout part of it. It's great when you're doing the small pieces, like if you're trying to make the text wobble or like a box wobble, but the actual layout itself wobbling becomes a little shady. Anything else? Cool, awesome. Thanks for your undivided attention. Have a good day.